Hello, in this video we're going to go over the block diagram for LTI analog system, and we have a few examples. We're going to go over them. Some of them are impulses, some of them are with integrals. So let's start with the integral one. So this is the first one. This video is going to be a bit short and a bit fast, so buckle up. So let's start with the block diagram. What you can see here is that you have like three impulses, which is P2, P1, and P0. And you have feedback loop with two impulses, which are minus Q1 and minus Q naught of 0. So how are we going to do this? So first of all, we're going to find W of t, which is right here, and W of t should be equal to the impulses on the left side, or or we can think about the integrals. So you start from the bottom one. So you have P0 or P naught. To pull it all the way up, you have to integrate it twice with this integral here and with this integral here to pull on the top and move forward to W of t then Y of t. So how are you going to do this? Let's go. So we got P naught double integral. First integral will be from infinity to tau, oh sorry, t, because that's your variable. And second integral is going to be from 0, and don't forget the bracket, from infinity, sorry, to tau. I'm going to use a dummy variable like phi, psi, whatever you're going to try to use, which is going to be x. I'm going to use psi, d psi. And all that with the integrated with respect to d psi here, and then the whole thing here in the brackets integrated with respect to d tau after all, because you have tau as a variable here. And now what happened is you're gonna do the p1 now. It has plus sign, so just add it, and it's gonna be p1 integrated only once because you only have to go through the integral once, and integrated from infinity to t xt, or tau, sorry, d tau. Last one is p2. This one is easy because plus p2, and it's just x of t because there's no integration playing the role. Now we're gonna do the feedback loop, which is I'll just call it y of t. And y of t is gonna be w of t minus, because you have minus in the q naught. I should not do it here. Probably is gonna do it downside, so it don't overlap. Minus q naught double integral as we did before, but this time the function is y, and you have the same limit. We have y of psi, dummy variable psi, d psi, d tau. And the second one is going to be minus q1, and only integrate once because you only have one integral between the y term and the q1 or minus q1. You call that the constant or the multiplier. And what you got here is from infinity to t this time, not tau, and you have y of tau d tau. Okay, that's the first one. Pretty straightforward. So you just need to substitute. Let me just use a different pin here now. You just read W of t by all of this right here. And you can also move the y of t's, the minus y of t, minus q0 integral, sorry, and minus q1 integral of y to the other side of y. You can do that as well, so you get a positive sign. So that's the first one. That's when you have integral uh, in your block diagram. Now let's move to the second one. which is purely impulses. So the way I do the impulses is that first I'll take the outside loop. So outside loop will be h1 t, and you take it's like you do meshes. So the first mesh is this one. So slide this, you take all, so you go from h1t to h4t, but since they're in series, so we just ignore the node here. It's gonna be convolution. That's a bad convolution sign, but like convolution with h4 of t. And since you have a plus sign here, you don't convolution with h3 of t, just add h3 of t. That's mesh, sorry, the outside mesh, so just put m out. Now, let's call this one mesh inside, the between h1 of t and h2 of t. It's got mesh inside, or mesh in. That's gonna be h1 of t, since you have plus sign here, and they both pointed toward the plus sign, and you only get two of them. You're gonna do it as convolution h1 of t convolution with h of 2 of t. So now what you do is you just add them to get the final impulse. Oh, so not the impulse, the pulse. So h of t is going to be equals to h1 of t convolution with h of 4 of t plus h3 of t plus h1 of t convolution with h of t of h2 of t. Just double checking the work. Yes, we get it right. So that's the final answer. And why we did convolution h4 of t and h3 of t? Because they both got the output. So you cannot like just convolution them because they meet in the output side. If they have a plus sign right here, for example, just hypothetically do it in different color like a blue, as they did here. So if they have plus sign here, yeah, then you can convolution them together. But they don't have one. But in the next example, we're gonna have a convolution that in the output sign and before the output sign. So we can